Hey guys, welcome. Let's go ahead and talk about our two main formulas to use with graphing. Our first one, this is called the heavy hitter. It is slope-intercept form. So what we're going to do today is we're going to break this up in kind of like two little mini lessons. You can use slope and y-intercept of a line to write and graph a line. So that's what we're going to be doing today. And our first one is right here. So I want you to go ahead and we're going to write at the top the title of this video at the top, and then I want you to write the essential understanding, and we're going to write our slope-intercept formula. So slope-intercept form is exactly what it sounds like. It's made up of a slope, which is we call m, and the reason why we call slope m is something I'm not sure why, to be honest. So if you want to research that and bring it into class and tell me, that would be awesome. Okay, and then we use b for y-intercept. Why do we use b for y-intercept? I don't know why. Maybe you can look it up and tell me. Maybe I do know why, and I just want you to do some research. I don't know. So look those up. Why do I use m? Why do I use b for slope and y-intercept? Because usually when we know why we use something, it makes more sense for us to use it for that. So slope and y-intercept. With those two things, I can actually graph. Let's go ahead and take a look at an example. All right, example one, first we got to identify what is the slope and the y-intercept. And what I like to do is I like to write the equation right above the problem, just like that. So write this line out and write the equation right above it. And there we can pull the slope, which is m. It's going to be 5. And I like to always write my slope as a fraction because it's rise over run. And then my y-intercept, b, is -2. Let's go ahead and graph that. We always start with the b. I always like to think as b for begin and slope as m for move. Okay? So b, we want to begin here. I'm not saying that's what the b, why it's called b, I'm not sure. It's just a fun acronym for us. But we're going to begin with a -2 on the y. So here's our y, our x. The y-intercept is where the graph intercepts, hits the y-axis. So we go -1, -2, we're going to put our point. The slope is our move. It tells me how to move. So I'm going to rise 5 units, and I'm going to run 1 unit. Okay? 1, 2, 3, 4, 5, and run 1. We're going to do that again. 1, 2, 3, 4, 5, run 1. And there we go. We graphed using point slope. It's slope-intercept. Very easy. We have a slope and we have a point y-intercept. All right? Okay. Just like we were taking the equation, we made a graph. We can also take a graph and make an equation. So which equation represents the line? Well, we're going to use our new friend, y equals mx plus b. And the reason why we're going to use this is because I can identify right here is my y-intercept. So I know that my y-intercept is -2, so I can actually plug that right in. Next, I need to find a second point that hits perfectly. So I think that point hits pretty good. How do I get there? I rise 1, 2, so my slope is going to be 2 over, and I run 1. And I throw the x in there, and the equals y. So we get y equals 2x minus 2. So we can take our equation, write it out, and we fill in from the graph by finding the slope, which we've done before, and this time we also have to find the y-intercept. Okay? Let's look at our second equation. Okay, our second equation, and this one actually is a little bit harder to use, but we are going to say that this one might almost be more important. And that's because as you move on in your mathematical career, this one can come up and helps a lot when we deal with transformations, which is a very big concept in geometry, also a big concept within Algebra 2 and Pre-Calc and so on. Alright, it's called point-slope form. And just like we had a form where it was slope-intercept, it was made up of a slope and intercept, this one's made up of a point and a slope. So we're going to have some point, x1, y1, and we're going to have a slope, which is still defined by m, and we have it right here, And what we can do is when you use this, you pick the specific points to represent any point and then use the slope to graph. So I want you to write all of that down, okay? And now let's move into 2 examples and we're done. Okay, so this is our first problem of this set. Overall, I think this is our 3rd problem, I think. Anyways, what is the graph of this equation, y minus 1 equals 2/3 x minus 2? So the first thing you want to do is you want to go ahead and write the formula literally right above it so we can pull out the pieces. Okay. Now the easiest thing to pull out is our slope, which is going to be 2/3. And then what we want to do is we want to go ahead and pick the point out. Now this is the hardest part. The point is x1, y1, and the difficulty here is the equation has a negative built into it, so when you see a -1, the y is actually positive. And there's a negative built into the equation, so when you see a -2, it's actually a +2. So how do I graph this? Right, because that's what the real question is. Well, in slope-intercept form, we graph the point of the intercept first and then use the slope to move. Here we do the same thing. We just, instead of going to the y-intercept, we start at whatever point we're given. Here's our point. And then we're going to use the move. Okay, so next we are going to use this to move. So we're going to rise 2, 1, 2, and go over 1, 2, 3. Okay. Now, conversely, instead of doing rise 2 over 3, I can actually go down 1, 2, 3, and back 1, 2, and I can go right here. So we can do both of those different directions. Okay, so it's kind of convenient for us. All right, let's go ahead and look at one last one. Okay, last problem. What's the equation of the line here? All right, well, it's kind of hard to tell. I can't really tell if we have a y-intercept, so we probably can't use slope-intercept form. So what we're going to have to probably use is use point-slope. And the reason why is because I know I have 2 points, and I can always find the slope. So let's find the slope first. Now there's 2 ways I can count. Let's do that way. Start on the left. I go up 1, 2, 3, 4, 5, 6, 7 units up. So that's 7 on the rise. This is my M. And then we can count 1, 2, 3 is my run. Can we reduce that? No. We want to leave our slopes as fractions even if they're improper because it wouldn't make sense to have a mixed number slope. So we have our slope. Now we just need a point. Well, we have 2 points. I can use either point. Let's use this one down here, x1, y1. And now let's write our equation. And, whoops, started that wrong. Y minus y1 equals mx minus x1. So what we have to do is plug in. My slope, we know, is going to be 7 over 3. My 3's never look good in this, I feel like. 3. That looks better. X minus x1 is a -2. Okay? Notice there's a negative in the equation, and then x1 itself is negative. Equals y minus y1 is -3. Now we don't want to leave our equation like this. We want to take care of those negatives, so that should become y plus 3 equals 7 over 3 and x plus 2. And that's how we do from 2 points, we can find point slope. We have to use our slope formula or we can count, and then we plug in a point and a slope. Alright guys, toodles.